This video is going to discuss the basic sampling methods that are associated with collecting data as it pertains to the course of AP Statistics. So let's go ahead and get into some vocabulary, and then we'll take a look at some practice problems, beginning with the population. So in a statistical study, the population would be the entire group of individuals that you are trying to collect information about. So you could think of the population as being this entire blue rectangle that you see off to the side. And within that population, we would want to conduct a census, a collection of data from every individual in that population. Now, that is the ideal goal, to collect data from everyone in the population. But the thing is, sometimes your populations would have so many hundreds, thousands, millions of individuals in it where it wouldn't make sense to take a census of everyone in that population or every individual in that population. In the United States or in other United Nations countries, for example, a census of everyone in the country is taken about every 10 years because it's not an easy thing to do, so it doesn't happen very often. Because of this situation, we take what is called a sample, which would be a subset or a subgroup of individuals that come from that population, and then we would collect data on only that sample. So you can see that right over here in the blue rectangle. A sample would be a smaller bubble within the population. And right off from the side, you can kind of see the grammar of how this situation works. You collect data from the sample, not the population, because that would take too long. There's too many individuals in the population. And you would use that data to make an inference about the population. An inference being a suggestion or a conclusion or an idea. So let's go ahead and take a look at an example. This one is involving cars and Twitter. So identify the population and the sample in each of the following settings. Consider pausing the video right now, reading A and B, and seeing if you can come up with that answer on your own. But here we go, part A. An assembly line at a factory produces about 500 cars a day. Each day, quality control managers inspect 25 cars at the factory and perform an in-depth review of each car. So the population in this case would be the 500 cars, and the sample that's being taken is the 25 cars that are chosen for the inspection. Part B, a politician uses a Twitter, now X, poll to find out whether his followers agree with a recent bill that was passed, and 432 people responded to the poll. So the overall population in this case would be the politician's entire Twitter following. It doesn't say how many people, but it is the entire following. And then the sample would be the 432 people who chose to respond. Let's take a look at some other ideas that are associated with sampling, beginning with a sample survey. A very basic idea. It is just a study that collects data from a sample. Nothing special, very obvious, a sample survey. But a sample survey does have a procedure so that you can properly plan how to do it and do it correctly, and there are three things to do. You would first want to decide what is the population that you are trying to find information about. Is it every student in your school? Is it every person in the state of Florida or whatever state you live in? Once you decide on your population, then you want to decide what you are trying to measure. Is it people's heights? Is it people's preference to if they want a pet or not? You would just kind of decide what you are investigating. Lastly, based on what you're trying to measure, you would then want to decide how to choose your sample from your population. And there are many ways of choosing a sample, so let's take a look at a few of them right now. Starting with the easiest and probably not the best one to use, a convenience sample. A convenience sample is one where your individuals are just very easy to reach, and the problem is you often get unrepresentative data. So let's say, for example, you're trying to look at the population of people in the state of Florida who like to own pets, and you are trying to measure that likelihood, and maybe on a scale of 1 to 5, 1 to 10, whatever. If you were to, let's say, take a convenience sample of only the people who live on your street, in your neighborhood, really easy to talk to all those people, they're really close to you, but the problem is you might not be getting an accurate representation of people who own pets and like to own pets. Maybe you live in an area where it's not as conducive to own a pet, a dog or a cat, or maybe you live in an area where it is easy to own a pet. Maybe there's a lot of land on your property and in your neighborhood, who knows? A convenience sample sometimes does not give you a good representation of the entire data set. And what that can lead to is something called bias. That is when your study is going to heavily underestimate or overestimate the value that you are trying to know. Another example of this, sticking with pets, could be, let's say you're sampling people who are walking around a shopping area and you happen to be standing near a pet store. It's probably more likely that you're going to interact with people who have a preference for pets because they are going in and out of the pet store. It's no guarantee. It's just that's what bias can kind of represent. A situation where you're going to be playing favoritism with one direction or the other regarding what you are looking for. And then then lastly, a voluntary response sampling system allows people to opt in by an invitation, meaning you are saying, hey, if you want to do this poll, for example, on the internet, go ahead and click right here. And the problem with that is not everybody might have access to the internet, or not everybody typically does internet polls. So that's another issue with voluntary response sampling. You get people who are maybe biased in one direction or the other because they are choosing to do the actual invitation that you are giving them. Let's take a look at another example, though. What is the average GPA? An AP statistics teacher was curious about the average grade point average of students at his school. He used the 32 students in his second period AP statistics class as a sample and concluded that the average GPA was about 3.85. What type of sampling was used and how was bias in this sampling method? How could that bias could have been avoided, and why did it affect the results? So once again, pause the video, give it a shot, but here we go. So the method used was taking a convenience sample since the teacher was using only the students in the same class. It was very easy to ask the students who were all in his second period class. So it was a convenient sample. Next, the bias would be as follows. So AP statistics students are much more likely to have a higher GPA because of the fact that taking an AP class adds an extra weighted average factor to their overall GPA. So it's going to pull that this convenient sample is going to pull a group of students that are already more likely to have a higher GPA due to the weighted average that is associated with taking an AP class or an honors level class. So the bias in this case would be an overestimation of what the overall GPA is in the entire school. And likewise, if the teacher took a sample of students who were in the lowest level math class in the entire school, then it might be giving an underestimation of what the GPA is, because if it's a lower level math class, then typically those students don't have as high of a GPA. Some other sampling methods. Probably the best option you're going to have is taking a random sample, and that is where you are using pure chance and probability to determine the members of that population that you are going to include. And you could use software like using the calculator codes that you can see right there. You are basically taking what is called a simple random sample, abbreviated SRS. And that's where each group of N individuals, maybe 20 individuals, 100 individuals, whatever it's supposed to be, are chosen from the population. Those individuals have an equal random chance to be selected. And there are, again, some ways that we will now look at for how you will take your simple random sample. So let's take a look at another example right here. This is one method where you are choosing an SRS with what is called Table D. And Table D is found in a textbook. You can find them online. It is a pre-generated table with many, many lines of random digits. So you can think of that capital D as referring to the letter D in the word digits. And what we're going to do in this case is take a screenshot of line 130 from Table D. If you were to look up a version of Table D and go to line 130, then you would see the string of characters that are right there circled in yellow. So here is how you use Table D in this case in order to take a random sample of, in this case, 4 hotels is what we're trying to take. Now, there is a 3-step process, and you should consider jotting this down. Step 1, you got to label with numbers so you can quantify it, all of the individuals that you are pulling from. So in this case, you can see the numbers 01, 02, 03, 04, all the way down all of these columns until you reach the last member of this group, the 28th hotel, the Veranda. And you label everything with numbers so that you can now make use of the digits that are in Table D. So here's what you would do next. Now for the randomization procedure, you need to take 2 digits from every string of characters in line 130 on Table D, and you just write them down as their own 2-digit string of characters. So I tried to color code everything for you, and we'll just start right over here with the first chunk of 5 numbers. Again, notice all of these numbers are 2 digits. Even though we have the numbers 1 through 9, you would list them as 01 because you are going to 2-digit numbers like 28. Notice how we take the first 2 digits from line 130 of Table D, and we write those down as the first string of characters. So 69 creates the number 69. You then continue with the next pairing of just 2 digits. So 05 would correspond to the number 5. And then if there's ever a space between your string of characters from a line in Table D, you ignore that space and you just write those 2 individual digits, this case being 1 and 6, as the singular number 16. And then that gets written down below. You continue this process. Again, look at the color coding. We have a 48 and there's a 48. Just skipping down the line, there is a purple 95, so there's a purple 95. You basically use all of the lines, all of the numbers in line 130 on table D to create enough two-digit characters where you can now make your selection. So hopefully this has been enough of an explanation with all of the color coding. This would be something to definitely drop a comment about if you have a further question about making this selection of numbers. But in essence, you take all of those digits and you split them up into pairings of 2 digits at a time, and now you can make your selection. So basically, you go from left to right along your string of characters, and you circle the exact numbers that you actually have in your entire list. So there was no 69th hotel. The highest hotel number was 28, but there was certainly a fifth hotel on our list, and that would be the Beach Castle. There was a 16th hotel, that was the Radisson, and then there was no 48th hotel, but there was a 17th, the Ramada Inn, and then no 87, you don't need a repeat, no 40th, 95th, so on and so forth, all the way until you get your 4th hotel, which was the 20th, the Sea Club. And then you will notice right here, I stopped because I got enough of the hotels that I needed. It only needed 4 hotels to be chosen, and this is how you use table D with randomizing your digits to make a selection. Hopefully this was enough of an explanation for that, because we are now just going to move on and look at another example. Good news. To promote positive classroom culture, Mr. Wilcox often asks his students to share good news. Because he doesn't have time to let every student share each day, he takes a sample of students who will share. So part A, describe how to use a random number generator to select a simple random sample of 5 students. This is just doing what we were doing on the previous page. We are going to start with labeling all of the individuals that we are trying to take a sample from, and there are 30 students in this class, and we can't ask all of them what good news to share, so we're going to label them 1 through 30, and then use a random number generator to choose 5 unique integers from the numbers 1 through 30. And once we have those 5 digits, you would then select the actual students who correspond to those 5 digits. And that's actually going to slide us right into part B. And again, if you pause the video to try this on your own, great. If not, then just, understand and learn from this example as we go through it. Part B, the random number generator at random.org was used, and we got the following digits that you see right below. Now, we are only interested in the first 5 students who would fit on this list. So that would be the numbers 4, 14, 21, 19, and 12. You would skip the second 14 because we already took the number 14, and we do not care about the 25 and the 2 because we were only taking 5 students. So you can see that the 4th student on the list was Gabby, the 14th student was Ian, and so on and so forth. I put a blue check mark next to all of the remaining students and where they came from. They just correspond to the numbers that the random number generator picked. And then part C, describe how to use the hat method, which is a very easy thing to do. I hope you didn't overthink it, but just to clarify, the hat method is as follows. You would begin by labeling the names of everybody in the class, all 30 of them, on pieces of paper, and then put it in a bowl or a hat, and then randomize things by mixing it up. And then choose 5 of those students, pull the 5 names, and those 5 names would be the selection of the students who would be sharing good news. Hopefully this example wasn't too heavy, and it was actually easier than you probably thought it was going to be. Let's look at some more vocabulary about choosing a sample. So there is such a concept called the strata, and your strata are the groups of individuals who share characteristics that might be associated with the variables being measured. The key thing there being shared characteristics. And your strata, the groups of individuals that you're going to take, allow you to use what is called a stratified random sample. And that is where you are choosing a simple random sample from each of the stratum. Those are the individual strata that are part of your selection. You are choosing a simple random sample from each of the stratum, and then you're combining those into one fair, homogeneous kind of sample. Now, what you're noticing off to the side is an example of that. So let's say you are investigating something that has to do with your school, and you could say your grade level is the strata. There are students who share similar characteristics as 9th, 10th, 11th, and 12th graders. So your strata, in this case, could be the grade level that you're looking at, because all of those students would be similar in 9th, 10th, 11th, and 12th grade regarding age. And then the random sample would be, and you can see the green X's in this little diagram, you would choose, in this case, an equal number of students from each grade level. You can see that two green X's appear in each of the grade levels, and that will allow you to have a fair representation of the entire school. So again, rather than just sampling students maybe in the cafeteria throughout the day, which might lead to more of one grade level being selected, you instead say my stratified random sample is going to involve taking all 4 grade levels and then a subset, a subgroup of each grade level, and we're going to take the same number of people from 9th grade, 10th grade, 11th grade, and 12th grade. That is a stratified random sample. We'll look at an example of that in a moment. Another way of taking individuals would be looking at clusters. And that is where you are taking individuals that are basically near each other, all chunked together. And basically, a cluster could be considered a classroom that students are in. And sometimes schools and administrators like to do a weapons security check. And the way they would do that to properly screen a classroom is they would choose one classroom, 2 classrooms, however many, and that classroom would be the cluster of all the students who would be properly screened for weapons. And lastly, we have what is a systematic random sample, and that is where you would be taking all of your individuals and putting them in an ordered position, and then you're randomly choosing, let's say, every 5th individual, every 10th individual, or you use a random number generator to tell you which individual to take in that string of characters. Let's just go ahead and look at an example of how these come into play, and that will hopefully clear things up. Oh, and one other way of doing that is just to alphabetize everybody who is in that systematic random sample. So if everyone was just sorted based on their last names, you could choose maybe every 27th person from that list, and that would allow you to get a random sample. All right, Mr. Gallup wants to know the average number of pages in all the books in the downtown library. The library has 20,000 books. They are arranged by type, fiction, biography, history, etc., in shelves that hold about 50 books each. So we have 20,000 books, and we have shelves that hold 50 books each. You want to select a random sample of 500 books. So, explain how to select a stratified random sample of 500 books. Well, your strata in this case, the best way to do it would be to choose based on the genre. Since all books belong to a genre, the genre could influence the number of pages. You wouldn't want to just take books off shelves at a random position of wherever you're going to walk around the library. The effect of a genre might cause a book to be longer or shorter. Some science fiction books are incredibly long, and that's just why you would want your strata to be the genre of all of the books. So you'd want to include all the genres in your stratified random sample. So let's just say there are 5 genres, and doing some quick math, 20,000 books total divided by 5 genres in the library would be 4,000 books per each genre. And then that means now that you have chunks of 4,000 books per genre, you can now number each book 1 to 4,000 in some maybe alphabetical order or whatnot, and then just use a random number generator to choose 100 unique integers. And from each of those genres, you would take 100 books, and since there are 5 genres that we are assuming in this situation, and you're taking 100 books from each genre, that total would give you 500 books. But the point is, you took 5 genres in the entire library. 20,000 divided by 5 is 4,000 books. So each of those 4,000 book genre categories, you would want to take 100 randomly selected books so that you're getting an equal distribution of fiction and an equal distribution of biography and history. And that is how you would do a stratified random sample in this case. Let's now look at part B. Explain how to select a cluster sample of 500 books. Remember that clusters are where you already have individuals chunked together. And if you choose a cluster, then you have to choose everyone in that chunked together group. So here's the way of doing that. Remember that each shelf held 50 books. So your clusters in this case could be the shelves, and those shelves might have, or they will have, the same genre of book. So basically, take the number of shelves, so there are 50 of them, so you would do 20,000 divided by 50 shelves. That means each shelf is going to have 400 books. So you would number your or there would be 400 shelves. So there would be a numbering process of 1 through 400 for all of the books on these 50 shelves, and then you would use a random number generator to choose 10 unique numbers that will go corresponding to each shelf. So you have 50 shelves. Each shelf has 400 books. The random number generator would, let's just say to keep it simple, choose shelf 1 through 10. 10. So now you are choosing the first 10 shelves, and you would count all the pages on all the books on those shelves, and that would allow you to get your average. Is it a quick procedure in this case? Definitely not, but it would at least ensure that you are avoiding bias to the best of your ability, or any other type of underlying factors that might not make your sample as random. All right, one more thing to look at, or three more vocabulary words and one more practice problem to look at. We have another concept called undercoverage. This occurs when some members are just less likely to be chosen, or they can't be chosen. So that would be a situation of you're calling phones to take a survey, but not everybody might actually own a phone, or maybe they just have their phone set to not allowing unknown phone numbers to reach them. Another situation is if you have a non-response, and that's when somebody just can't be contacted and they refuse to participate. They might have initially signed up, but then you can't reach them, and oh well, in your sampling survey you have some non-responses, and that's just part of the process. So people sometimes just say no to being involved with the study. And then lastly, there is response bias. This is a really big one to be aware of. That's where there is a pattern of inaccurate answers. Maybe the wording of the survey guides people in the direction that isn't allowing a randomized option to be selected. Let's just take a look at an example so you can see how these kind of come into play. So sometimes bias occurs when people respond to interview questions, and they will respond dishonestly because of the pressure of giving socially acceptable answers. Many studies have been done on this, where a group of people are asked about an answer that is a fairly obvious answer to some, but they just kind of feel pressured to raise their hand and say, oh, I agree with everyone else in the room because I don't want to be the only one not raising my hand. In the 2016 presidential election, most polls predicted Hillary Clinton as the eventual winner. Donald Trump surprised many people when he was elected as the 45th president of the United States. Explain how this idea might have affected the poll's predictions. So let's just go ahead and let this solution kind of play out. This isn't meant to be political one way or the other. This is just something that happened in 2016. We had what is called response bias occur. People may have felt like they did not want to admit to others that they voted for Donald Trump, because at the time in 2016, he was not a very popular candidate amongst the masses per se that was all around, media and being talked about, and just there were comedians making fun of him, and it just wasn't being taken seriously. So people who were clearly voting for Donald Trump lied about voting for him in exit polls because they didn't want others to know that they were voting for him. And yet he won the presidential election anyway. So therefore, the response bias caused an underestimation of the amount of votes for Donald Trump. And that's just because some people feel there are social pressures to giving certain answers, and because of that, they're just going to be dishonest. There are many instances of these situations coming up, and that is why homework is there for you to practice. So I hope this video was informative, and we will do more practicing in class, and I will see you guys next time.